Welcome back, dear students. Today we shall discuss a new concept, that is support and reactions from elements of civil engineering. First of all, we shall understand what is support. Support is a structural member which resists when applied load and provides the stability to the structure, wherein reaction is a force exerted by the support in response to the applied load. Today we shall understand how many types of supports we have. This is most frequently asked question in your exam. The first one is just a simple support. What is this simple support? This simple support, say if this is a member, it has only the vertical reaction. First of all, we shall understand why the supports are given. We know we have 3 translation motion and 3 rotational motion. If you want to restrict the motion in any of the directions, then we provide a support. Now, coming to the next support is hinged support. So for hinged support, it has a vertical reaction and an horizontal reaction. Mean to say that it can withstand both forces in vertical direction and forces in horizontal direction. Coming to the next one is a roller support. What is this roller support? As the name indicates, it rolls in one particular direction. See, this is a roller support. When we apply a load in vertical direction, it provides a reaction in vertical direction. Mean to say that it restricts or resists in vertical direction. But when we apply a force in horizontal direction, this starts rolling. So there is no reaction in horizontal direction. And we have one more type of support, that is fixed support. This fixed support, it's quite simple. For this, we have a reaction in vertical direction as well as reaction in horizontal direction. In addition to this, we have a moment. So this is one simple question wherein you can expect in your exam that define or explain with a neat sketch how many types of supports we have. Thank you. Dear students, I have considered 3 positions of the support. Most of the students go wrong during solving of the problem. Now what we need to do, as I discussed, this is one hinged support. We have a vertical reaction as well as the horizontal reaction. The direction of horizontal reaction depends upon the direction of the applied force. Now, in this position, you can make out this is vertical and this is horizontal. It's quite clear. Coming to this particular, if the support is inclined at some angle, say theta, how do you take the reaction is quite important. Now, always remember, the reaction is normal to the surface, say 90, and towards the surface. Next, in this you can make a note, this forms a triangle. Next, sum of all these 3 angles will be 180 degree. If this is 90 degree and this is theta, obviously this is supposed to be 90 minus theta. Now, this is a reaction. If I consider one point, say B, this will be RB. Now, whenever there is an inclined force or a reaction, we need to resolve it. So, resolving this to vertical as well as horizontal. So, what is vertical reaction and horizontal reaction here? As I told, this is 90 minus theta. If I take this angle as theta as 30 degree, 90 minus theta would be the 60 degree. Proceeding further, we know when we resolve the inclined forces, we have cos component and we have sine component. Now, the most important thing is here is angle measured with respect to horizontal to incline, that is 60, that is horizontal to incline, this will be 60 degree now. So, resolving, we have RB cos 60 degree and RB sine 60 degree. This challenges comes when there is a support at inclined position. Now, you can also observe here, this is normal to the surface and towards the surface. Coming to this particular, as I told, say take some angle 20 degree. Now, I take this reaction, say some point C, I will call this as RC. As I told, this is 90 degree and 90 minus theta would be this, so this would be say 70 degree. Now, resolving this to horizontal and vertical, make sure angle is measured with respect to horizontal to inclined, that is horizontal to inclined, this angle will be 70 degree. So, this particular will be cos RC, cos 70 degree, and this will be a sin RC, sin 70 degree. This is the most important concept you need to understand if you wanted to solve a numericals. Thank you. Welcome back, dear students. Today we shall discuss different types of loads. So the first one is point load. As the name indicates, it is a type of a load which is acting at one particular point. It is also known as a concentrated load and an imaginary load. Next, we have one more, that is uniformly distributed load. Simply it is called as UDL. As the name indicates, the load is uniformly distributed throughout the length. So this is how it is shown, and if this is the length L and say W kilonewton per meter load is acting, and it can also be shown in this particular way. If this is a beam member, so it can be shown in this particular way also. Next, we have uniformly varying load, which is also known as a triangular load. As the name indicates, the load is uniformly varies from 0 to the maximum intensity. Or we have one more option. If this is a beam, from the maximum intensity, the load can deplete to 0. Say if this is the length and say this is the overall length. Say here the intensity is 0 and here it, say for example 12 kilonewton per meter, and again say somewhere here it is 15 kilonewton per meter, and here it is the intensity might be 0. So these are the different types of loads which they ask in your final exams. Make sure that you will practice well. Thank you. Dear students, I have taken few examples from which you need to understand how to analyze the loads and the moments. The first example is, there is a beam with a point load. How to take a load if it is a point load? Whatever the value given, directly you take as a load. Quite simple. Next, how to calculate the moment? We all know moment is equal to force into the perpendicular distance. Taking point A as a reference, this is a load and perpendicular distance would be this 2 meter. So 10 into 2 is equal to 20 kilonewton meter would be the moment. Next, similarly now we shall analyze if it is UDL load. Now how to take a load? It is quite simple, 10 kilonewton per meter, but we have 4 meter length. So 10 into 4 is equal to 40 kilonewton will be the load. Next, how to take a moment? As I told, moment is equal to force into its perpendicular distance. In case of UDL, the load is always concentrated exactly at the center. So this would be 2 meter and this would be the 2 meter. I am just dividing the overall length into two parts. Now moment is equal to load, as we have calculated 40, that is 10 kilonewton into overall length is 4. So 40 into perpendicular distance would be with respect to A, as I told, it always concentrates at the center. So say take the center distance, that is 2. So 80 kilonewton meter. Next, proceeding further, In case of triangular load or a UVL load, we have two possibilities. That is, here the load factor remains same for both case. Load is equal to half into base into height. This is a simple formula for a triangular load. Now, half into 5 and 12. If you multiply, you will get a load. Even this is same for this triangular load also. The next case is how to calculate the moment. That is the most challenging point. Now, as I told, moment is equal to force into its perpendicular distance. I have already calculated the load here. Next point is calculating the perpendicular distance is the unique thing. So, if I am measuring with respect to A, say I will assume I have a 2 points here and 1 point here for triangle. So, if you are measuring with respect to 2 points, the distance would be the 1/3 of height. Height is not this one, please make a note. This arrow mark is directing towards this distance, so this will be your height, that is 5 meters. So now 1/3 of fifth distance supposed to be taken to calculate the moment. Therefore, moment is equal to what? This half into 5 into 12 into the distance would be 1/3 of 5. So this is the important point you need to concentrate. Next, proceeding further for this triangular load, it remains same, that is half into base into height is the load. Next, moment would be taking this support as a reference. As I told, I have 1 point here. With respect to 1 point, if I try to calculate the distance, this will be 2/3 of the height, that is 5. You can clearly make a note, if you are measuring with respect to 2 points, it is 1/3 of its height, and if you are measuring with respect to 1 point, it is 2/3 of its height. Therefore, moment is equal to what? Half into 5 into 12 is the load, and its distance should be with respect to A, that is 2/3 of 5. This is how you analyze when you solve the problem. If you have learned all these things clearly, 50% of your job is done in case of solving numericals. Thank you.